Today's opener, as I said, is going to be closely resembled to the notes that we took yesterday for at least the first two problems. The last two problems we're going to take more notes on today. When I go to add or subtract fractions, what do they both have to have before I can just simply add them? Kelly? What about the denominator? It has to be the same. They have to have a common denominator. In order to get a common denominator, we can do it either by finding the least common multiple or by simplifying your denominators together. So if I multiply, did I say simplify here? No. By multiplying your denominators together. So if I multiply 4 times 5, what do I get? If I multiply 4 times 5, what do I get? 20. So that's going to be my new denominator. So if I come up with a new denominator, I'm also going to have to come up with a new numerator. So if I took 4 times 5, that's okay, fix it. If I took 4 times 5, there's another opener on that clipboard if you want to grab it. To get 20, I also have to take my numerator times 5 to get my new answer. So what's my new numerator going to be? 15. Okay, so I'm done with that fraction. Now I have my second fraction. So I multiplied 5 times what to get 20? What did I take 5 times to get 20? 4. So then I have to take what two numbers multiplied together to get my new numerator? Well, say it again. No, well, the 5 times 4 got me my denominator, my bottom number. So how do I get my new top number? What two numbers do I have to multiply for my top number, my numerator? Jaden? And the 2 times the 4, right? The 2 times the 4, which equals 8. So whatever we multiply our bottom number by, we multiply our top number by. Now, you guys' calculator does all this work for you, but I just want you guys to understand how to work it out if you don't have a calculator. Now that I have common denominators, I can move on to step 2 of my notes, which is add my numerators. So if I add my numerators together, what's 15 plus 8? 23. Do I add my denominators together? No, it stays the same. The last step of fractions is to do what? What's my last step for fractions? Fractions suck. Why? We have to simplify. Can I simplify 23 over 20? Are they both even numbers? Nope, so I can't divide by 2. Can I divide both of these numbers by 3? By 5? No. So that's in simplest form. So it's going to be 23 over 20. Now, how many of you guys just used your calculator to do the work for you? And you got 1 and 3 over 20. So when you do that, that's a mixed number. What I want you guys to do, when you get that answer, hit second, hit the fraction button, hit the equal button, and it'll get you back to an improper fraction. Okay? So I don't want mixed numbers. I want improper fractions. Okay, let's look at the second one here. Again, most of you guys probably just use your calculators to calculate, but I like to make it hard on myself and work it all out. So when I go to subtract these, what's the first thing I have to do, Danielle? Can I just subtract them? Why not? Why can't I just subtract these fractions? Yeah. Are my bottom numbers the same? No. So how can I get them to be the same?
Subtract them.
Not subtract them. Can somebody help her? Jalen? How can I get these numbers to be the same? No. Multiply them together. Or you can find the least common multiple using your multiplication chart. So if I take 3 times 7, what do I get? Anybody? 3 times 7 equals 21. So I'm putting my new fractions underneath here. So I just said 3 times 7 got me to 21, right? So if I multiplied my bottom number by 7, I multiply my top number by 7. So what's my new numerator going to be? 14, good. So I'm done with this fraction. Now I move to my second one. So I took 7 times 3 to get to 21. So if I took 7 times 3, what else do I have to take that 3 times? the 6 to get my new numerator. So 6 times 3 is? 6 times 3, say it again. When you add them, you get 9. 18. Now, I just changed that to yellow. I don't want that yellow. Now, just looking at these numbers, 14 minus 18, what's our answer going to be? What kind of answer are we going to have? A positive or a negative? Negative. So what's 14 minus 18? Because we can now subtract our numerators. Say negative 4. Remember, your negative can go right in front of your numerator, or it can go right in front of your fraction bar. It cannot go down in the denominator. And then 21 minus 21?
0.
But do I do that?
Nope.
Nope, my denominator stays the same. Can I reduce negative 4 over 21?
Yes.
By what?
Not, I guess.
Okay, that's okay. Can I reduce negative 4 over 21? Is it divisible by anything? No. So we're done. So we're going to box it. Trash one. Moving right along. Now we have the 2 new parts that we're going to talk about today. I love multiplying and dividing fractions. I don't like adding and subtracting them. They're hard to me. But I love multiplying and dividing fractions. There are 2 ways that I'm going to teach you that you can multiply and simplify. I like to simplify at the beginning. When I multiply fractions together, I'd rather simplify at the beginning because it gives me smaller numbers to work with. So when you simplify at the beginning, you can reduce any numerator with any denominator. Okay? So I can reduce any numerator with any denominator, but I cannot reduce the numerators and denominators together. So I'm going to look at my first numerator, 2. Can I reduce 2 and 15? Can I simplify 2 and 15? No. What about 2 and 8? Yes, they're even numbers. What are they both divisible by? 2. So what's 2 divided by 2? 1. That's my new numerator. What's 8 divided by 2?
4.
That's my new denominator. Good. Now, when I get to 1, that's simplest form. So I go to my next numerator, and I check it to see if I can reduce it with any of my denominators. Can I reduce 9 and 4? No. Can I reduce 9 and 15? Yeah, by what? What are 9 and 15 both divisible by?
5.
No.
Wait, no. I'm sure.
So always start with 2. Are they even numbers? Nope. Are they both divisible by 3? Yeah. So what's 9 divided by 3? What's 9 divided by 3? And then what's 15 divided by 3? 5. So here's my new numerator, my new denominator. Now when I multiply, I just multiply straight across. So multiply your numerators together. What's 1 times 3?
3.
And then multiply your denominators together. What's 5 times 4?
20.
And because we reduced at the beginning, it's already in simplest form. Now, I'm going to do it another way in purple. You do not have to do it. I just want you to follow along. And I need your help. Oops, that's not purple, is it? So 2 over 15 times 9 over 8. So when we multiply fractions, all we do is multiply straight across. So what's 2 times 9?
18.
Okay. Then what's 15 times 8? I don't know what that is. You guys are going to have to use your calculator for me. Say it loud. 120? Now, those are big numbers to simplify, right? So what's 18 and 120 both divisible by? Are they both divisible by 2? Are they both even numbers? Yeah, so they're divisible by 2. So what's 18 divided by 2?
18 divided by 2 is
9. And what's 120 divided by 2?
7.
Close.
6.
60. Okay? Is this in simplest form? Is 9 over 60 in simplest form? Yes or no? It's 9 over 60 in simplest form. Can I reduce this any further? Always ask yourself, you guys, is it divisible by 2? Do they both end in an even number? No. Are they both divisible by 3? Can you divide each of these numbers by 3? Yeah. So what's 9 divided by 3?
3.
What's 60 divided by 3? Close. What's 60 divided by 3?
20.
20. So we end up with the same answer, but I feel like the way in the purple is a lot more work because you're working with larger numbers. So I always like to reduce at the beginning. All right, last one. When I divide fractions, what mnemonic device or acronym do I use to help me remember how to divide? Carlos and Nimmons, what did they teach you for dividing fractions? It makes us all hungry. Makes us want to eat. KFC, remember? We're going to keep, we're going to flip, and we're going to change. What that means, we keep our first fraction the same. We flip the second fraction. So if I flip it, it's going to go to 4 over 3. That's finding the reciprocal. And then the change, we're going to change the division sign to multiplication. And now we just follow multiplication rules. So, again, I like to reduce at the beginning. So I can reduce any numerator with any denominator. So can I reduce the 5 with the 6? Can 5 and 6 be reduced? You guys are killing me.
No, Miss Liddy.
No, thank you, Mr. McFarland. I hope you pass your quiz on Friday.
Good job.
Can you reduce this numerator 5 with this denominator 3?
No.
Do you guys understand what I mean by reduce?
Yeah.
Okay. Can you reduce this numerator with this denominator? What about this one with this one? What are they both divisible by? 2. So what's 4 divided by 2?
2.
And 6 divided by 2?
3.
Now, I've reduced as far as I can, so now I follow my multiplication rule. So I multiply my numerators. So what's 5 times 2?
10.
And then multiply your denominators. What do you get when you multiply your denominators?
18.
3 times 3. Remember, because we canceled that 6
9.
out. So
9.
3 times 3, 9. And since I simplified at the beginning, I'm done. Now, if you got in your calculator 1 1/9, that's where you have to hit second fraction button equals to get it back to that improper fraction.